Unit 3, factoring. Factoring is really not going to be a big unit in terms of tests and whatnot, but it is important because you have to be able to factor in order to solve quadratics and then solve polynomial equations. So this particular lesson is not one that will be taught in class. This is available to you online in case you need to review from Algebra 1. You should, from Algebra 1, be able to factor a greatest common factor, a difference of squares, a perfect square trinomial, or just regular trinomials. You should also know that you can multiply polynomials back together again to find the equivalent standard form. So let's get started. First, factoring is rewriting an expression as a product of prime factors, the greatest common factor, or GCF. The first step when factoring should always be to look for a greatest common factor, and then you remove it first. So these few problems are greatest common factor only, and sometimes that's the only thing there is. What you do is you look at 17 and 51. Do 17 and 51 have a common factor? Well, you might not be sure. You do know that 17, I hope you know, that 17 is prime. But what about 51? Well, you can do a quick check and say 51 divided by 17 and find, oh, it goes in 3 times. So 17 is a common factor. So you can sit there and, let's do this, and say I've got 17. This is a common factor. And then a and a cubed. A is also a common factor. So I'm going to divide 17a out of both of these, and I wind up with 17a times 1 minus 3a squared b. This is factoring out the greatest common factor. Again, that's taking out a number and or variables that are factors of all terms. Terms are those items that are added or subtracted together after everything has been combined that can be combined. So again, we look at 14xy, 18xy squared. Let's look at the numbers first, 14 and 18. Always then go to the smaller number, 14. Well, 14 won't go into 18. Going down from there, we have 7. 7 won't go into 18. 2. 2 will go into 14 and 18, so that is my common factor there. Then I have an x and an x. I can take an x out of both. I have a y and a y squared. I can take a variable with the smallest exponent. So that means that I'm going to divide this by 2xy and this one by 2xy. Whatever the common factor is that I take out front, what is left inside the parentheses is whatever is divided by that common factor. So 14 divided by 2 is 7, and the x and the y cancel. So I should have 7. Over here I'm going to have 9y. Notice there's my 2xy, 7 minus 9y. All right, pause the video for a moment and try these next two. See if you can get these. Did you pause the video? And when you're looking back, did you get 2xy, x squared y minus 8x, y squared plus 4? Great. And what about this next one? Were you successful getting 4x times the quantity x squared plus 3x minus 2? Okay, notice at this point, I am not in any way, shape, or form asking you to do anything more than just greatest common factor. Okay, so greatest common factor, it is the number and variable or variables that come out. Always, this should always be the first step. Now, we move on to the difference of squares. The difference of squares is when you have two terms. You have a perfect square minus a perfect square, thus difference. A sum of squares, no. This is a difference of squares. So the difference of squares is simply a pattern. A plus b times a minus b. Why does it work? Well, a times a is a squared. A times b is ab. Negative b times a is negative ab. Negative b times b is negative b squared. AB plus negative AB makes a zero pair. So it drops out and you're left with the a squared minus b squared. Again, it's just a pattern. So in our examples down here, we have x squared minus 4. Well, that would be x plus 2, x minus 2. Now, does it matter if you put the x plus 2 or the x minus 2 first? No, it doesn't matter at all. I typically put the subtraction second. Every once in a while, you'll have a difference of squares that when you factor it, the subtraction part is another difference of squares, which is why I tend to put it second so it can just keep going. But there's nothing special about it. Next up, we have x squared minus 49. X squared is a perfect square and 49 is a perfect square. Using our pattern, we have x, the square root of 49 is 7. So it's x plus 7, x minus 7. Now if we want to get things that are a little more complicated, we have 144x squared minus 9y squared. It's okay. This whole piece is a perfect square. 9y squared is a perfect square. So we can do 12x plus 3y. And then we have 12x minus 3y. Oh, but wait. There's a greatest common factor here. 3 will come out of both of these. So I have 3 times 4x plus y. 3 comes out of the 12 and the 3 here, so it's 3, 4x minus y. Now the 3 times the 3, I should put that together and make that 9. And I have 4x plus y, 4x minus y. This is a case where I took the greatest common factor out after I did the difference of squares. Could I have done it beforehand? Sure. If I'd done it beforehand, you would find that 144 divided by 9 happens to be 16. So you would wind up with 9 times 16x squared minus y squared. And when you factor this guy, you're going to wind up with this as your final answer. This is completely factored. Yes, you must factor completely. That means greatest common factor and difference of squares. Both have to be done. Okay, let's look at this next one. 8x squared y to the 4th minus 16. Well, I notice that I've got 8 is not a perfect square, but 8 will go into 16. So we're going to have 8x squared y to the 4th minus 2. Now here, you can't do anything else. This is not a difference of squares. I can't do anything else here. I'm done. Okay? Just making sure that you guys realize sometimes just because things want to be a difference of squares, they're not necessarily. Okay, then we have one last one down here where we have x squared y to the 6th minus 289. Any variable to an even power, okay, any variable to an even power. If I take the square root of this guy, I will get that variable to the even power divided by 2. Just little info. So any variable that has got an even power, it's a perfect square. So x squared, perfect square, y to the 6th, perfect square. And 289 is the perfect square. Its square root is 17. So I'm going to have x, y cubed plus 17 x, y cubed minus 17. Bada bing, bada boom. There it is. Factored. It's a pattern. Factoring factoring a difference of squares should not take long. Factoring trinomials. Okay, this is where we want to be a star. You can use the box method, or you can use the star method, or you can use divide and slide, or you can use guess and check. You can literally use whatever it is you would like to use. It's fine with me. I don't care. Okay? The only thing that I ask is that you stay consistent and that you use a method that works all the time. So, if we factor trinomials when a is equal to 1, that's actually the easiest thing. In doing that, in this key concept, I just cut and pasted from the textbook that you would be using. So it's an example there. Identifying factors of c that sum to b. You can list them all out, but hopefully you can also do it in your head. This is something you're thinking of. If I'm factoring x squared minus 17x plus 72, a is equal to 1, b is equal to negative 17, and c is 72. Okay, remember that the standard form of a quadratic is ax squared plus bx plus c. So, I need factors of 72 that will add up to negative 17. One way that you can write this, just to help you focus what you're doing, you can do this. Say I need factors of 72 that add up to negative 17. Now, one thing that I do is I do this and this. This just kind of helps us when we go to rewrite. This tells me I need two things. I'm going to multiply to get 72, add to get negative 17. Since they multiply to a positive but add to a negative, I know both values have got to be negative. Now, I can go through. What two will work? Well, 1 and 72 won't, 2 and 36 won't, and I run through my head and I realize that I have 8 and 9. So negative 8 and negative 9. Negative 8 times negative 9 equals 72. Negative 8 plus negative 9 is negative 17. When a is 1, this next part becomes easy. It's just called bottoms up. So I just move the ax term from the bottom up, and I wind up with x minus 8 and x minus 9. Pretty straightforward. Okay. Next, I need factors of negative 12. So I'm going to make my star. I need factors of negative 12 that will add to negative 1. Because my product is negative, I have one negative and one positive factor. Ax, that's just 1x and 1x. And again, this is so that I can do my bottoms up. So I run through and I think about, here are my factors, and I find that my negative 4 and my positive 3 are the ones that work. You can list your factors of 12 if you need to, or you can run through them in your head. Either way. Again, because a is 1, I don't have to worry about simplifying anything. So I just do the bottoms up, and I have x minus 4, x plus 3. These are really fairly simple, and you don't really need the star unless you haven't been factoring for a while and you're still struggling a little. The star, again, can help you just focus your attention on what it is you're trying to do. Next, factoring trinomials when a is not 1. Okay? And that is ax squared plus bx plus c. Always, always, always remove, please remove any greatest common factor or factor it out. That makes everything easier. Then mentally identify a, b, and c in the remaining trinomial. Multiply a times c. Now you have two ways to proceed, the box method or slide and divide, which I don't really like slide and divide. We're going to call this the star because we're not going to really rewrite things. So how do we do these? Well, I've got the box method, and I listed out slide and divide here because I know there are a number of Algebra 1 teachers who teach slide and divide. So the box method, slide and divide. They're listed here. You can pause the video, read them, go, oh yeah, I remember, or oh no, I don't. I'm going to be using the star in class. So if we go ahead, and again, here's an example of 6x squared minus 32x plus 10, and I've done step 1, step 2, step 3. And then I've gone on with the box method and slide and divide. You can pause the video and read and work through. Forward through. Again, pause the video if you need to. And then to see the rest of it, there it is. Okay? Now, what I do is very similar to slide and divide, but it's a little different. So here, let's get this one started. I sort of combine slide and divide and box, kind of a graphic and a quickie. I do A is 2 times 7, and I get 14. The middle term is 15. Now, AX, I'm going to have 2x and 2x. I now need factors of 14 that add to 15. Well, that's 14 and 1. 14 times 1 is 14. 14 plus 1 is 15. Now, before I get my final answer, I'm going to rewrite these fractions. 14 over 2x and 1 over 2x. Before I can do bottoms up, I need to simplify the fractions. Well, this one simplifies to 7 over x. This one is already in simplest form. Now I can bottoms up. And because these are positive numbers, I can put a little plus sign in front. And my final answer is 2x plus 1 times x plus 7. Or you can have x plus 7 times 2x plus 1. These are the same thing. Remember that 2 times 3 and 3 times 2 are the same thing. Now, grouping, and again, I don't care what method you use. You can do slide and divide, you can use the star, or you can use the box. But pick something and stick with it. Excuse me. Grouping 4 terms. We need to group 4 terms. Most of the time you're going to group 2 and 2. Okay, most of the time you will group 2 and 2. So if we do this, I'll group the first 2 and the second 2. Then I'm going to do greatest common factor twice. Here I can get an x squared out, and that leaves me with x minus 5. This plus comes down, I can get a 3 out, and that leaves me with x minus 5. Notice that I have x minus 5. I have the binomial term x minus 5 is common to both of these. So if I factor it out of this and of this, I'm left with x squared plus 3. I've factored by grouping. Over here, before I start this whole crazy thing, I notice that all of the numbers are divisible by 3. So I'm going to take the greatest common factor of 3 out first. And that gives me x cubed minus 2x squared plus 5x minus 10. I'm going to come back in and I'm going to group. So I'll group the first 2 and I'll group the last 2. I have to keep my greatest common factor out here. And then here, x cubed, x squared, I can get an x squared out. And that leaves me with x minus 2. Then I have my plus, and then I have 5 comes out of this one. Oops, let me do this. I put this guy didn't go there yet. Sorry. I have my 5, and then I've got my x minus 2. Now notice that within these two, I've got an x minus 2 that is the same. So I've got 3, and I've got my x minus 2, and that leaves me with x squared plus 5. Factoring by grouping is really just doing greatest common factor and then greatest common factor again. Okay? Greatest common factor, then greatest common factor again. Down here, we've got this one. Oops, let's go 2 and 2. Well, if I do this, I'm going to get y squared plus x squared, or plus x, and then y squared minus x, plus 3 times 2x minus 3. Didn't get me anywhere. So that didn't work. I can't just group 2 and 2. This is an example of one of those times when it's better to group 1 and 3 or 3 and 1. So here's what I'm going to do. This y, I don't have any y's down here, but I do have an x squared and an x. So I'm going to group these 3 together. Because this is a subtraction, I need to change this and this. Okay? Because I got the negative on the outside of the grouping, I have to change all the signs. Now, I have y to the 4th minus. In here, I've got a trinomial. I need factors of 9 that will add up to negative 6. How about negative 3 and negative 3? That means that I have x minus 3 times x minus 3. This one is going to become a difference of squares. I have y to the 4th minus x minus 3 quantity squared. Now I have a perfect square and a perfect square. The square root of y to the 4th is y squared, plus the square root of x minus 3 is just x minus 3. Now I'm going to have y squared minus x minus 3. I have to distribute that subtraction sign, that subtraction symbol, get myself down here. So now I've got y squared plus x minus 3 times y squared minus x plus 3. Now this one has been factored by grouping. This is a special case. Most of them will be like the first two. Occasionally you will need to factor to group either the first 3 and leave the last one alone, or group the last 3 and leave the first one alone. In summary, to factor a polynomial, write the equation in standard form. Remove the greatest common factor if one exists. If only 2 terms and subtraction, is it a difference of squares? If so, use the pattern. If it's a trinomial, use the box method or slide and divide, or use the star. You can quickly factor a perfect square trinomial if you recognize the pattern, which I put there. If you don't recognize the pattern, don't fret. It's easy enough to do the star, box, or slide and divide. The last one there is check your factors by multiplying them together to see if you get the original polynomial. You do have grouping as well, which is group 2, greatest common factor, or group 1 and 3 or 3 and 1. Okay, that's it. That's your Algebra 1 review. You also should have a graphic organizer and a foldable to help you with all of this review. When we get to the factoring unit, you need to be ready to go because there's really only one new way to factor and a way to make this all just a little more complex. Not terrible, but a little more. See you then.